All right, so now we are at the last set of our notes. We're going to take a look at absorption and elimination in the intestines. Now, absorption and elimination, especially the absorption part, we kind of forget about that because we think about digestion. We think about just chewing and swallowing. It goes in the stomach, and we break it down, and then we eliminate it into the toilet bowl. But we forget about the absorption part. The whole point of breaking down all of these large molecules into smaller ones is so that they can be absorbed, so that we can feed our cells. And those nutrients then get transported into our bloodstream and then around our body to all the cells besides just those in our digestive tract. So that's the goal of digestion. Let's take a look here at our next body part here. We're going to take a look at the jejunum. The jejunum is actually, it's easier to see on here, is in this upper section here, this upper corner here, that's the jejunum. So before we had talked about the duodenum coming with the stomach right here, and then it would empty out through the pyloric sphincter into the duodenum, and from there it then goes into the jejunum, and this is the jejunum here. Now the jejunum is where most of the food absorption takes place. It's suspended by the mesentery. I'm going to flip this around so you can see this here. So this gray area here, this is a tissue here that is holding up all of your intestines here. It's about 25 feet in there, and it's held up by that mesentery. Now it will contract and extends easily to allow the food to move through. And below there is the ileum, which we'll get to here in a moment. Let's take a look at the villi, because like I said, there's absorption that's occurring inside of the small intestines. Now the villi are these bumps here that are all along the sides of the intestines. Doesn't matter if it's the duodenum or the ileum or the jejunum, they're all in there. All right. So what's going to happen here, I'm going to move my picture over, is that the monomers are going to move across that microvilli, right? And then they're going to have absorption occur through the cells. So it's going to come through the nutrients, then into the blood, into the capillaries, and into the blood, and then delivered to the bloodstream, and then out throughout the cells. Now I have another model here. Here's my other model. Here's a bigger model of the villi here. You see how big they are and how the food would fall in between. Right? And we can also see the blood vessels in there as well too, the capillaries, and how the food, the nutrients would absorb through the cells into the bloodstream and then out throughout the body there. All right. Okay, so let's talk about the ileum. All right, so the ileum is, like I said, the other corner here. This is the orange looking intestines here. And this is where you're going to finish up your food absorption, and you're also going to start water absorption as well. And again, that is suspended by mesentery. So we got the duodenum, where we're going to finish up some digestion, and then we got the jejunum, where we are going to start absorbing the food and the nutrients, and then we have the ileum, where we're going to finish up the food absorption, and we're going to start with the water absorption. All right, so now we've made it out of the small intestines, and now we're into the large intestines. Okay, so the large intestines, all right, here's our model here. Here's the large intestines. Okay, so the large intestines are going to connect with the small intestines, and you're going right here, right there. And then from there, it's going to go up, over, down, around, and then go to the back here, and then out, right? That's what's going to happen here. That's the path we're taking with the large intestines. Now, take a look at our large intestines there. When it enters, we're going to the ascending colon, and then the transverse colon, descending colon, through the sigmoid colon, this little curve here, and then out through the rectum, and then through the anus. Now we also have the appendix here. And a lot of people say, well, the appendix doesn't do anything. Well, it used to do something. And what it does now might be a little bit different. There's a lot of research going out right now that is saying that it is used for a colonization of good bacteria. All right, so we have bad bacteria and good bacteria that we're going to talk about later here. But the good bacteria, when you get sick and you empty out your bowels, we got to repopulate those large intestines with the good bacteria. And there's research coming out that says that that's where that good bacteria is hanging out, is in the appendix. Now, you don't necessarily need an appendix. If you have appendicitis, it's taken out and you can live a fulfilling life without it. All right, so let's take a look at the functions of the large intestines here. Absorption of water and sodium, incubation of coliform bacteria, that's that good bacteria, and the elimination of waste. Those are the three main functions. And you see that there is some friendly bacteria and some unfriendly bacteria here. And some of this friendly bacteria you can actually get from eating yogurt. That's why a lot of dietitians will say eat yogurt if you have upset stomachs, stuff like that, because they can actually help clean out that bad bacteria. It has a lot of health benefits as well as releasing vitamins and help with the production of those for your body. All right, so the water. There's water absorption going on in as well, and I was talking about the polarity of water. If you're taking chemistry class or physical science class or maybe even biology class, I know you've talked about polarity of water at some point. So this should be kind of a review for you. Now, the water molecule, it is positive on one end and negative on the other. What I mean by that is that there are more electrons on one end and less on the other. The more electrons you have, the more negative you are. So the oxygen side is actually more negative than the hydrogen side, which makes the oxygen side considered to be the negative region and the hydrogen side to be the positive region. All right, now because of that, because you have those polar regions there, that polarity, two things can happen. One, it allows other water molecules to attract to other water molecules because opposites attract, negative, positive, positive, negative. It also allows water to become a universal solvent. So we can dissolve a lot of things in water. Water will attach to them, and then we can then use the water to help transport those things around. And when I'm talking about that, I'm talking about ions and salts that we're going to see here in a bit. So right here, salts dissolved in water, universal solvent. So here's a picture of that oxygen. Here's that hydrogen. And the oxygen is slightly more negative than the hydrogen side. So over here is negatively charged. Over here is positively charged. And so the negative oxygen region will attach to the positive sodium ion. All right, so we see going on right there. And then on this side, this hydrogen, right, it's more positively charged, will start to be attracted to the chlorine ion there. Okay. So what this does is this is salt, NaCl, right? That's salt, sodium chloride. When you put salt in water, you can do this right now. You could go get a glass of water and put a little bit of teaspoon of salt in there. When you mix it up, what's happening is those water molecules are pulling the sodium chloride that are together, that make up that white salt that you have. They're pulling them apart, and they are separating them as we see in the picture here. Now, you can change it up by going ahead and boiling away the water or letting the water evaporate, and then you eventually have that white dust, that salt again, at the bottom of that glass or pot if you do any boiling. Now, our cytoplasm is actually a salt solution. All right, cytoplasm inside of our cells. So like I said, salts will dissociate. They come apart in the water, right? And when they do, they are called electrolytes. Oh yeah, electrolytes. We see that in a lot of commercials now. Everybody's talking about electrolytes. You need to get your electrolytes, right? So what are they? They're just ions, right? And so if you are working out very hard, then yes, you go ahead and grab yourself a Gatorade. But take a look at the serving size on it, because sometimes those Gatorade bottles might have more than one serving size. And you're also getting a lot of sugars in there too. So if you don't need to replenish the electrolytes, then you're just drinking a sugary solution. And that may not be good for your diet. All right? If you're not burning up those calories, what do they become? Fat. All right? So just a little health tip there. So when the intestine absorbs the water, it's also called absorbing salts, or it's also going to be absorbing salts, vitamins, and minerals at the same time, because, like I said, those are all dissolved in that water, that universal solvent. Some common ions are listed here: sodium, magnesium, phosphate, calcium, chloride, and carbonate, right? Those are all common electrolytes that we see. And then why do we need these salts? Well, they're great for nervous function, for muscle function. We'll take a look more at the sodium-potassium pumps when we get to our muscular section. And then blood clotting, and also in fluid balance as well, right? So thinking about tonicity and hypertonic, hypotonic, isotonic solutions from biology class. I hope it's ringing a bell. It should. That's what we're talking about when we say fluid balance. Now, the large intestine has no villi, right? It has none of these big bumps along in there, right? And it has no enzymes either. But it does contain pouches called haustra. Now, those haustra, these little bumps here, right? That's how we're going to move along the food, using segmentation. What I mean by that is that as the food moves through, these pouches will contract, and then the food, or now it's going to become the waste, will move up, and then it'll contract and then move, and contract and then move. And what this does is allows time for more absorption of the water to occur as your food or your digestive material becomes your waste that you will no longer need, right? And so this is what we're going to start calling out feces. And feces is just water, bacteria, cellulose, dead cells, few bile salts, and pigments as well. But it's all coming out through your colon there. So after water absorption, what is left is turned into feces and eliminated out. So we go through the sigmoid colon. All right, so the sigmoid colon, we look on our model here. This part here is the sigmoid colon, right here. And then from there, it'll go to the rectum and then out the anus, right? So the rectum and then out the anus. Now, stretch receptors are what's going to trigger that defecation, right? So there's going to be some stretching that will occur inside the rectum there towards the sigmoid colon, and then that is going to tell your body, okay, it's time to defecate, it's time to empty. All right, now there are two sphincters. One is involuntary, and that's your rectal sphincter, okay? That's this one right here. You don't have control over that one there, but you do have control over the anal opening. Sometimes I feel like we don't have control over it after that Mexican meal. But we do have control over that, and to a point, and that is why we say it's a voluntary action there. All right, so that took us all the way from the mouth, all the way through down the esophagus, the stomach, to the small intestines, large intestines, out the rectum, or through the rectum and out the anus. And that is how we get our food and break it down into the smaller molecules from those larger pieces, like the pizza that I ate. We'll break that down and absorb into our cells. All right, I'll see you in class.